We have two equations to solve. These are exponential equations because the variables are located in the exponent. So our procedure for solving exponential equations is to try to get the same base on each side. This one has a base of 4 on one side, a base of 32 on the other. Definitely not the same number. To get a common base, I have to take the bases that I have or something smaller. So because 4 is the smaller base, I'm going to start with that. Can I rewrite 32 as 4 to a power? And unfortunately, I can't get it to be 4 to a nice integer power. So now I have to start thinking about changing both of these numbers to be a different base. So I've got to go smaller than 4. Well, I definitely can't rewrite 4 as 3 to a power. Ooh, but I can with 2. So how about 32? Yeah, I can also write 32 as 2 to a power. And if you need to check that, you can, of course, on your calculator. Just start taking powers of 2 to see if you can get to 32. Alright, so what about 4? 4 is 2 to the second power. But then all of that needs to be raised to the 5 minus x. Now for the other side of the equation, 32. 32 is 2 to the 5th power. And again, use your calculator if you need to get to that. And I need that to be raised to a power of x. Okay, so now we've rewritten with the same base. Now use rules of exponents. Power to a power, or exponent to an exponent, you multiply the exponents together. So on the right side, I'm at 2 times the quantity. I got to distribute through 5 minus x. On the right side, all I have is 5 times x, so 5x. So if I do my distributing in the exponent on the left, I get 10 minus 2x equal 2 to the 5x. My bases are the same, my exponents are simplified. Set the exponents equal to each other. 10 minus 2x equals 5x. That's 10 equals 7x, or x equals 10 sevenths. Okay, now what about the next problem? 9 is the first base. The second base is 27. So again, definitely not the same base to start with. 9 is the smaller one. Can I rewrite 27 as 9 to a power? Not a nice integer power. So I have to start thinking about, well, what are some bases smaller than 9 that I could use? And when I think about exponents, for 9, the only one I see is 3. A 9 is 3 squared. And then again, I need to raise all of that to the x plus 6. Now what about 27? Can I rewrite 27 as 3 to a power? And yes, I can. 27 is 3 cubed. And once again, parentheses, and then keep the other exponent that we had, which was x minus 2. Okay, now simplify with rules of exponents. Got to distribute to when we multiply the exponents together. So on the left, we'll get 2x plus 12 after distributing, and on the right we get 3x minus 6. Bases are the same. Set the exponents equal to each other. So I'm going to subtract the 2x from both sides and add the 6 to come to the answer of x equaling 18.